Presentation did. Yeah. Alright, so for my presentation, I made one function as f of x equals ln of x, and the other one is negative ln of x, and it was pretty simple and made like a parabola shape. And then I used like the same things like we did on that one project. So I just made one of the points a of f of a, and then the other one was a of g of a, and I did the last one with absolute. And then I used one point, so it pretty much made a right triangle because you have like the segment at the bottom. And so, yeah. So it made a right triangle with those 3 points, and then I used
Alan Williamson.
I pretty much made it from 3 to 7, and I took the integral of that to get the volume. Oh yeah, I have the rest of these on my paper. So like once I explain this, can I like use?
You follow those lessons so that you.
Oh yeah. Name of solid. I don't know what to call this. I guess I called it right triangles. Okay, graph of the base shape, the f of x equals ln of x and g of x equals negative ln of x. Volume of the solid by adding all the slices of volume. So can I just call on my paper now because the rest is on papers?
Just switch to the document camera.
I use this integral right here, 1/2, and then from 3 to 27 to f of x squared dx. That's how I got the volume of all this of the area right there, 332.56, and then volume of the solid by doing the integral. Digital 3D model. We already showed the digital 3D model with all those right triangles that we're moving. Here's like the graph of each volume, slice of each volume. It went from 2.197. So pretty much the base and height are just the same thing, and then times both of those by each other. I don't know, base times height squared divided in half because the right triangle is pretty much the same as like a square cut in half. So then the slice volume gradually goes up to 1 to 3 to 27. So oh yeah, and the volume of that. I just used the integral function from f to 3 to 27. I got 61.69 on the top half, and I used integral from from g to from 3 to 27 to get the same thing on the bottom half. And any other challenge that I've overcome? This 3D model right here I printed. This took about like 5 hours to design, like by hand on something called Fusion 360. I got like the numbers and everything, and here's all the right triangles increasing. And then to print this whole thing out, it took 12 hours. And it finished last night at 2 a.m. Actually, this morning at 2 a.m. And I had Mr. Brown open the door for me because Mr. Gerber wasn't here. And yeah, this is really tedious to make. But if you're good at 3D printing and stuff, you can make this in about like maybe 2 hours. But for me, I've never done something like this, so it took like 5. Yeah, that's my presentation.
Name of solid, it is a trapezoid. Graph of the base shape. Well, the base is just, there you go. If the function is, there's 2 functions to it. There is a x to the power of sine x and negative x to the power of sine x. And the volume of the solid is 148.154. This is the 3D model. I cut it with cardboard. There's a lot of very small pieces, so it doesn't really look that nice.
Go this way so people can see that.
This way? This way?
Yeah, so people can see it.
Yeah, there you go.
I can tell you're like, oh,
I don't want it to fall and break.
do something.
The challenges of this was that the pieces were really small because of the function, and it was really hard to cut and make them like exactly the size it's supposed to be and try to put them together, so it's kind of unstable. Suggestions to modify, probably not to make a trapezoid or like something like that with really small like pieces or with really small base and width, because it's really hard to put them together. And what I learned that it's really hard to make one of these, especially out of paper and cardboard, and trying to make it look nice because it just doesn't look nice at all. But I tried. Yeah, there's my presentation. Thank you.
I call my solid the Kamehameha wave.
kind of looks like one if I add glue to it. And the graph of the base shape is f of x equals square root of x, and then g of x equals negative square root of x. I just use that generic one that he gave us. And so I didn't do the volume of the solid by adding all the slice volume. But then I calculated the volume of it would be 50 units cubed, or 250 centimeter cubed, because I scaled it units to centimeters 1 to 5. So every 1 unit it will be 5 centimeters. And I do not have my, or I have my 3D model, but I couldn't show it on here. And any challenge that I had to overcome. So yeah, cutting the cardboard was pretty hard. It was like tough getting the measurements right when cutting it too, because cardboard doesn't work with you that well. And for modifying this, I think I'll add a little more color to it. It looks a little plain. And what I learned from this project is to not procrastinate, because it's pretty stressful doing it last minute. Yeah.
Really, 10 whole minutes.
Yeah, that's public audition. All right. So, do you want to start here, and then we'll go to that. We'll go to that, and then we'll go to that. Okay.
Yeah.
So, actually, just kidding. Do that first, and then. So, this is our. Me and Michael did our project together. So, let's lift it up first. So, this is what it looks like. No, you look, yeah. And then we'll show. So, it's a bow tie, as you can see. We made it in construction, and so we made like the two halves separately, and then we tried to like join them in the middle with this rebar, and it kind of like broke out the bottom a little bit, and it's like curvy, and yeah, so that didn't quite work out, but it still looks good. So that's all right. The base is, let's do the whole thing. So the base is sine and negative sine, as you can see there. Matching. And then in the middle, because sine and negative sine would reach like 0 in the middle, so we put the two lines, what was it, y equals 3, and then y equals negative 3. No, y equals 1/2 and negative 1/2, so it's going to be y. And so, yeah, we made our 3D model. That's what our 3D model looks like. And then...
Rotate it so we can see.
Oh, yeah.
Rotate it to the other.
So yeah, there's that. And then this isn't scaled up, right? So our project, we scaled it up 12 times, so it's 2 feet wide instead of 2 units wide. So on our, on here, so this is, yeah, this is the actual dimensions and stuff. So the position, we have negative 12 to 12. It's a little off the screen, but that's like because it's 2 feet wide. So each of those units is an inch. And then, so the slice width, the equation we used there was 12. It was the absolute value of 12 sine of x over 6, just so that it could scale up.
If the chunk in that like stays the same in the middle.
Yeah, so that chunk in the middle stays the same because that's this middle block. And then the slice height, the cross section is a rectangle that's half as tall as it is wide. And this material we used is 3/4 inch millimeters. So our volume is 3/4 times the slice height times the slice width, which gave us a total volume of 1,043-ish square or cubic inches. So that's what we got by these slices. And then if you look on here, nope, there we go. We did the actual integral, and so it's 1,023 with just the curvy parts, and then we added in the block part in the middle, and that gave us a total actual volume of 1,036. So those were really similar to each other, which is cool. And yeah, that's our integral project. Where do you want this?
If you turn off the solid view, you can see all the individual cross sections, which, since it's symmetrical across the x-axis, could be cloned over, and which the software allowed you to take cross sections and combine it into this curve, which you can see runs along the tips. The function itself is of x sine 10x plus 0.5. I use GeoGebra, but the file's at home.
What software this one? What software this one?
It is this one right here.
No, the software.
What software is that?
This software is called Onshape. It's a web browser-based CAD. One big problem I found is at the points where the function gets really small, the printer had a hard time printing it, so it ended up just printing nothing between them. So you have to pretend due to the resolution being too low. So
Extra credit.
in future, I either scale it up or pick a function that had a less severe point. But yeah, no, I just took the various lengths out of GeoGebra and then went one by one into the sketches in order to take each cross section with the correct offset, and then once they were all added together, got a good old function that could be 3D printed. Yeah, it's about.
You save that file. You save the file.
How do you want me to send the end file to you or like a link?
Guys.
Okay, so this is mine. It's a pyramid. So it's the cross section using equilateral triangles of absolute value x minus 4 and negative absolute value x plus 4. I have my GeoGebra file, which shows the 3D model, which is right there also. Where is my map? Okay.
Can we just refresh them to start from beginning so they can see the
Yeah.
If you stop playing and you zoom in, it'll.
But if I stop playing.
Just zoom a little bit.
zoom in.
because we don't really see the slide.
Oh.
Yeah, that now we see the slide. That's how it build the pyramid.
Just let it spin. Like if you
Yeah.
do it, it'll start spinning.
Sorry, it goes slow.
I forgot how to make it move like that. You just put animation on for the slider.
If you click on the slider, we change the step. To make the step go a little bigger. Yeah, right click. Right click on the slider.
Use it to
Yeah. Go to the property. And
get out of the
Bottom.
ditch.
Yeah, I'm not gonna like mine.
Increment, make it like, make the increment, you see that?
Wait, where's the increment? Oh, okay.
Make it like 0.1.
Make it a little bit bigger so we really see slide. Otherwise, just build a solid.
Look at my graph. Look at this.
Oh, you want to see the? Okay, I see what you're
So
saying.
now you see like, like
Just think
Exactly.
about how World War I is pretty good.
Okay, yeah. This
Now
now,
we
okay.
can see
I
the-
see what you're saying.
Now we see the slide. Just move them up. And slide.
now it's not just smooth.
Allowed it.
Okay. So I used a similar program as Gray, where I just built all of my slices individually and I combined them all into a curve.
And you said you made an equilateral triangle?
Yeah, so these are all equilateral triangles. So yeah, that's why it makes the pyramid shape.
How'd you make your 3D model?
It's the same program as Gray. So I basically did the same thing. I had a whole bunch of planes set up. So I would make a equilateral triangle, and I'd move over 0.5, and then I'd make a smaller equilateral triangle, and I'd do that until I got to 0, and then combine them all into a curve. And then if we go here, here's my math. So in the actual like graph, it would be 73.9 units for the integral, but in reality I used 54 grams of plastic because it's half scale. But I also had infill, so that's why it was higher than. So yeah, that's it. Am I missing anything?
I try to digest because like the thing you say you try to put in how much of plastic is that the volume, that's the capacity.
That is the volume, but it's slightly hollow in the inside, so it's.
Or then the hollow.
Yesterday I bought some foam, but then the foam like disintegrates, so I couldn't make the foam structure. And then yesterday was trash day, so I didn't have any cardboard, and so I couldn't do anything. So I just had to do this for now, but I'll turn up the 3D thing later. But my function was 2 parabolas, like the reflection of the parabola on the top side to the bottom side. And like when you look at it from this perspective, it looks like a yo-yo sort of. And so I calculated the volume using squares. And that's
Are
the
the-
3D volume.
Are the cross section circles or what?
No, it's a square.
Squares.
Yeah, squares. And then the table, it went from 0 to 4. So to have 24 slices, I did 1/6 for each slice. So I did 1/6 all the way to 24/6, which is just 4. And then I just did the math for the Excel. And the math for this, it came out as 109. And the volume from the slices came out as 110. So it came out pretty close.
And then the interval of 0 to 5. And then my second equation would be g of x negative sign, and then it would be quantity of 3 times pi over 4x minus 1 minus 1.73, and the same thing is the interval will be 0 to 5. The only problem with this is that literally at 5, g of x doesn't reach it by like 0.005. So like it's kind of undefined for it. And it's just really small. And plus, I messed up on the volume right here. I was supposed to square this part individually. Individual for f of x and g of x. And then, so this would be each slice. So I did it by increments of 0.5 all the way up to, well, I tried to do all the way up to 5. The only problem is, 5 was undefined, so I just did 4.9. So once I added all, this is the correct volume, which is 125.25. And then, you want me to pull it up, Mr. Chun, on the GGR?
You can put you can talk about your model.
Oh, so yeah, my model, I use a box cutter, and I try to cut it out, and I kind of did it really fast. I was supposed to put this on top of this so that it goes up, so the middle one's supposed to be on top of this. I messed up. I did it really fast. I actually glued all of it at once, so there was a lot of glue like drooping and all that because it was like 1 a.m. I just had to get it done. Wait.
That one's your model.
Yes.
Which one?
No.
What did you think of it?
No, this cute is sweet.
If we make it circle, it would be a lot nicer.
Yeah, if it Yes, I know. Hi, Tyler. Okay, so this is my card. What was it? Animation on?
You close the 3D.
Which one?
Make it transparent and close the close one of them and make the window bigger.
Animation on.
Rotate them.
See, it was supposed to shift up, but you know, I did it right in the middle. It was my model.
It's really nice. Yes.
See, you're supposed to. Oh, no hand. It looks so nice.
It looks kind of like the top, your like top lip.
Yeah.
You know, like the top lip in like one of those.
Plus, I ran out. So.
I mean,
Like-
you look
like-
at the surface from the top down.
I mean, look. So like, what it
It
does
looks really
is.
nice. The surface from the top down.
I'll show this real fast. See.
Well, you said necro.
Yeah, the neck rest.
Oh yeah, that's a
Yeah,
good
it's supposed to
one.
shift
Yeah.
up.
Hashtag airplanes.
Yeah.
All right, that's it.